I guess, going to see some of chapter 6. So we are starting the course right now. And we started from chapter 6, section number 1. So it's called 6.1 because of that. So today I just want to give you a brief introduction into the story of angles and how they're being measured. And turns out that we measure angles in terms of degrees or in terms of radians. Yes, you do have a homework to do. And I will tell you the homework problems at the end of the lecture. And you access homework by looking at the lecture recording. And that's what I was actually talking about a whole hour last time. But I can repeat it. That's a good question. So homework coming from this textbook. So how do you access the homework? You open this textbook. So if you don't know how to open it, here's the link to it. I put it just in the Zoom chat, so you can click on that link, and what I have on my screen will appear on yours, the same textbook, not same page, but the same textbook. And what you need to do is save it. So you click on that, save it. And of course, it's a good idea to watch a recording of previous lecture because it's all there in very detailed. So I hope you'll find the time sometime over weekend, maybe. So anyways, let me start to discuss the angles by noticing that if we rotate all the way around and return to the same position, people say it's 360 degrees. So that's called a full rotation. So 360 degrees. So in terms of this number of degrees, we can produce various other angles, such as a half rotation, for example, that will be 180 degrees if you go just by half of it, half of 360. Or you can also go by half of this 180, which is 90, right? Divide by 2. 180 is 90 degrees. And this is going to be so-called right angle. Right angle is 90 degrees, is usually shown by placing this little box in the corner. So whenever you see the box, it means it's 90 degrees angle. And if you don't see the box, if they just gave you some kind of angle that looks like 90 degrees, well, it doesn't have to be 90. It may be 89 or 91 or something else, maybe close to 90, but we doesn't mean that we have 90 if they don't put this little box. I'm talking about this. So make sure that you pay attention to that. So don't automatically say it's 90 degrees angle if there is no box in the corner. So then you can break this into various other pieces. For example, you can break this into 3 equal pieces and get 1/3 of 90, which is like 30 degrees, or other angles. Somebody can say, Alex, we can get a 180 degree and 2 and 22 degree. Yeah, you can get all kinds of measurements, but these are the most popular. That's why I'm trying to show you those angles. It turns out that angles also may come with the negative sign. In fact, we rotate by 30 degrees counterclockwise, but we could also rotate by 30 degrees clockwise. And then the angle will be measured negative 30 degrees. How about that? So clockwise rotations come with a minus sign simply because it shows you in which direction you rotate. Because if somebody just puts 30 degrees, well, is this angle number 1 or angle number 2? Looks like they are a little bit different, especially if you're going to plot them on the XY plane. So if you use this favorite X and Y plane, then going down or going up is definitely not the same. And that's what we are actually going to do. And we can also notice then that same exact angle, let's say the one that looks like that, and that could be a favorite 45 degrees angle, for example, could be actually produced two ways. You could either go like that or the opposite direction. So you may say, it looks like sides of this angle are the same. And in the book, they call them initial side and terminal side. So where the angle starts and where angle ends. But turns out that even though sides are the same, but the angles are going to be different. And that's what they're trying to show in the figure 2, that you may go the opposite way and end up with the same initial and terminal sides, but the angle is going to be different. And turns out for that angle I produced, I need to actually take away from 360, 45. So it looks like it's going to be 315 degrees. So that's, I think, interesting observation that the same angle, like here, for example, you can produce more than one way. In fact, you can produce it infinitely many ways. And that's what the third picture is trying to tell us. So you could also rotate all the way around and then a little bit more and end up with the same exact initial and terminal sides of the angle, but that angle is not going to be the same because it looks like it'd be 360 added to what you had originally, let's say to 45 degrees. So that'd be something like 405 degrees. If I treat, of course, this angle as 45 degrees, like an example I made up. So you can get all kinds of degree measurements for the picture. And that's a little bit different compared to favorite XY plane, where each point on the plane had only one pair, XY, and no other way to present it. But looks like here we can rotate clockwise or counterclockwise, or we get rotated more than once and still end up with the same thing. So there are lots of ways to get the same thing. And that's something that I want you to realize. That's a little bit of a difference, in fact, quite a bit of a difference compared to what we learned before, because now looks like our possible solution may not be unique. And that's what we're going to see in this class. And I guess we'll return to these ideas again and again. So I hope you will be getting used to it. So other part of the story is, I guess here they draw in various angles, is to go to the section end and to do some of the exercises. And that's actually what you're supposed to do for the homework. So if you check out the end of the section, you will see some problems that they recommend us to do. So here's 6.1, and I'm going to look at the groups of exercises here. And for these groups of exercises, I can see there are 3 blueprinted groups, such as, are you prepared? Well, you are prepared. You're in this class, so you are prepared. So this is something that you don't need to worry about. Analogously, this vocabulary exercises, well, I'm not making you do them, but we're actually discussing it right now. There's initial side, terminal side of the angle. So you will know it anyways, and that's why I don't think you need to worry about it. But what we actually going to concentrate, and that's where you should do your homework from, is so-called skill building exercises. So I will always do problems from this little group of skill building. In fact, that's probably the largest group in each section that we cover in class. And then at the end, there are word problems. So they call applications. I can scroll down a little bit here. So applications and extensions. So you don't have to worry about those because I know that most people don't like word problems, so I don't make you do them for your homework. But if you want to, you're welcome. You can definitely look at those problems as well. So I'm going to take a look at exercises today that deal only with degrees, because there are other ways to measure those angles, but we should start to get used to this little circle that is called degrees. And next time, of course, I will be doing more of this section, and this more is referred to the other way to measure angles in so-called radians, but not today. I think today we'll just want to start. So, for example, the exercise like problem number 14 that says, what about negative 120 degrees angle? How about if you make a picture of it? Well, it looks like we already discussed that idea that we need to go somehow clockwise, right? For the negative angles. We always start at the x-axis, at the positive direction. So you take this so-called origin point, 0, 0. And now you need to decide 120 degrees. How does it gonna look like? And turns out, if you divide 360 by 3 equal pieces, that will be 120. In other words, if you rotate it somehow clockwise and ended up here, so the angle is going to look like that, negative 120. So whenever it's with a minus sign, then you get clockwise rotation. Well, it turns out that besides degrees, if you think of angle measured 1 degree, is going to be a very, very small angle, very, very close to 0. So it's going to extend and so forth. And that 1 degree angle contains other little measurements called minutes. So they state that 1 degree is the same as 60 minutes. So they put the prime instead of writing word minutes. So if you break this into 60 little pieces, then each little piece will be giving you 1 minute. So it's very difficult to see, but it's there. In fact, if you get a very big piece of paper and you just get the tiny angle for a while, then it's gonna be a little bit apart, and that's how we're going to get it. So what was for the homework for today? Well, you needed to download the textbook. That was the homework. And if you don't have a device other than cell phone, the homework was get it for free at the college library. In fact, I always refer my students to the college library because in that place, they have people that help you, not just selecting some kind of textbook, but actually with the technology, because nowadays library deals with technology. So if you don't have a cell phone, don't have a laptop computer, you should go to the college library and pick it up with your student ID. So that was another part of homework. And I talked about it last time and also made a recording of it and emailed it to you. So you should also check your student email, not some other emails, student email account, and you will see all information in it, such as lecture recordings, the syllabus that I emailed earlier. And that was third part of your homework, to make sure that you have access to that student email. And again, if you don't, well, that's fine. You can just go to the college library and they will give you this access. So that's very important thing to do for the first week of class. And if you didn't do it yet, well, then you should do it before the weekend, because on the weekend, college will be closed. The library, I don't think, is going to be operational on Saturday and Sunday. So anyways, going back to the story, I'm going to notice there are some exercises here that deal with this little symbols such as minutes. Like, for example, 23 has a degrees, minutes, and there is one more measurement, which is called seconds. And in 1 minute, well, I'm sure you all know there are 60 seconds, and those seconds we put with two little primes. So 1 minute is 60 seconds. So these two definitions are being utilized in this group of exercises starting at 23. But what they want you to do is also realize that since 1 degree is 60 minutes, then when you divide both sides of this statement by 60, since this is equation, then you can do that, right? Then what you're going to get will be 1 minute on the right side. And the expression for 1 minute is a degree divided by 60. And similarly, from the second definition, you can get a expression for 1 second in terms of minutes if you simply divide both sides by 60. And I'm sure that's something that is familiar, so you know that 1 second is actually 1/60th part of a minute. So last time I also discussed that in the lecture recording. So maybe you should check out the lecture recording, because all of these questions are answered there, and it took me quite a bit of a time. So to be quick, it'd be chapters 6, 7, 8, and 9 for that question. But I'm glad that you have those questions in mind. And again, you should check your email and watch the lecture recording if you did not, or if you missed something. And that's the reason why I email you those lecture recordings, because I know that when you're a student in class, there's lots of distractions around, and you may be with us, but in the next minute something happens and you don't pay attention and you miss something. And that's why advice is to always review those lecture recordings over maybe weekend. And I also told that homework you could do by simply redoing the same problems that I've done in class, the same exact exercises, be good enough. So anyways, this is 1 minute in terms of seconds. I should have been careful, I put degree in terms of seconds, but my goal is also to put it in terms of degree. So looks like I could utilize this fact and notice that if a second is 1/60th of degree, so you have to divide 1/60th by another 60. So I put another 60 in denominator, so it'll be 1/60 times 60, 3600. So that's for degree. So these two formulas I'm going to utilize for exercise 23. And turns out that when you have formula, you could just plug the numbers in, and that's really making life easier. So let me try problem 23 with 40 degrees and which means plus, right? 10 of those seconds and plus 25 minutes. So I'm going to go with the 10 seconds, which is going to be actually 10 times 1 second, right? And analogously, 25 minutes is 25 times 1 minute. Oh, it's a minute and a second, sorry. 10 times 1, and that's 25 times 1 second. You say, Alex, why do you need to do this cheap trick multiplying by 1? Well, it's the same thing, but now I could utilize these two formulas that we just produced. So instead of 1 second, I can produce 1 over, oh, instead of 1 minute, I don't know what's wrong with me today. Instead of 1 minute, I produce 1 over 60 degrees. And instead of 1 second, I'll produce 1 over 3600 degree. See, that's the way to turn everything into those degrees. So there'll be 10 times 1 over 60 plus 25 multiplied by 1 over 3600. And of course, people do this much faster. People just say, okay, instead of 10 minutes, they put 10 60s. Instead of 25 seconds, 25 3600s. But again, to do this, you definitely want to use a calculator. So let me show you a free scientific calculator here. So I just typed scientific calculator, and there is a choice number 1 for scientific calculator in Google. I know some people like to use other search engines, so this so-called Desmos calculator may not be choice number 1 if you're using something else, but in Google, it's a first choice. So you actually go 10 over 60, because we don't really put these symbols called degrees, and then plus 25 divided by 3600. And we produced the number. So this is 40.1736 and a bunch of ones. I say, do I have to copy all that? Well, you don't have to. You could just put ... and that way you will be producing the answer. Because if you look back at this exercise, the question to it says, write this in terms of degrees. You say, oh, Alex, they also want to round it to the nearest 2 decimal places. Well, if you put these digits, then you can, of course, round this and get something like 40.17 again degrees. So instead of those minutes and seconds, they produce degrees. So these kind of conversions are very popular in science classes when you convert one type of units to the other type of units, or if you took arithmetic or basic mathematics, you probably were seeing conversions of, say, inches to feet or to yards, or other measurements convert tons to pounds and so forth. And the idea behind that conversion I just shown you is exactly the same as for the other type of exercises that also appear in various sciences. So if you understand how we did that, then you can do anything in the sciences. You just need to know definitions. You just need to know, say, there are 60 minutes in 1 degree and so forth, and then you can turn degrees into minutes and vice versa. In fact, the exercise here, like number 29, wants you to go vice versa. Notice they put it in this different orange color in order to give you, well, advice that this is one that they recommend to do. So this was problem 23. I'm gonna do another recommended problem, number 29. And problem number 29 wants us to actually convert this backwards. And how to convert this backwards? Well, turns out we used to divide by 60, right, to produce the actual number. And then we divide it by 60 times 60, which means that you divide it by 60, and then you divide it by 60 again to produce those seconds. So now instead of dividing by 60, to go back, I'm going to multiply it by 60. And that's what we need to do in number 29. So if that's 40.32 degrees, then I already know this has 40 degrees in this, plus, and now there's 0.32, I have to multiply back by 60. 0.32, should be careful. I need to multiply back by 60. So I will get minutes. And again, the explanation why this goes is here. We can say that it's going to be 0.32 degrees. So 40 is already here. And instead of 0.32 degrees, because we don't have a whole number of degrees, I write this times 1 trick again. So I'll have 0.32 times 1 degree. And this times 1 degree again enables me to use the definition, but the original shape. So I'm going to put 0.32 times, instead of 1 degree, times 60 minutes. So notice, instead of 1 degree, I can put down 60 minutes, and that's what actually makes it multiply by 60. I know that people usually don't say it, but I think if you see once why we do this, you might feel a little bit more comfortable with this conversions. So anyways, let me go back to the calculator. Looks like I need to now deal with the product of this decimal. Okay, so let me multiply. So I advise you to get a calculator. In fact, a good idea will be to actually use this same calculator that I use in class, because I will use it all the time. And I think this is a very good calculator, not because it's free, but because it's actually showing you everything on its screen. So let me put the link to this Desmos calculator here in the chat, so you can click on it and open it up and just get used to it. Again, you will, because in class demonstrations we'll utilize this calculator all the time. So anyways, looks like now this 40 degrees will be added to the product of these two guys, right? And that happened to be 19.2. And notice these are already minutes, because instead of degrees, I put that little prime, minutes. So now I know that this is 40 degrees plus 19 minutes. And this 0.2 I need to turn into seconds, right? So 0.2 will be timed by 1 minute. So instead of 1 minute, I put these favorite 60 seconds, right? Since 1 minute, I put 60, this double prime. And again, we don't, if you go to tutoring lab, most likely they will tell you not to worry about these little steps, just times 60 and then times 60 again, and you get your result. Oh yeah, syllabus I posted on Canvas, and I also have syllabus emailed to you, so you can check your email. I sent it last week by email. It says pretty much same thing as on the Canvas, so either way is fine. I prefer not to use Canvas much because it is confusing program. People always get confused. I have every day about at least 10 emails, seriously, that say, Alex, on the Canvas it says, and so forth, and I need to clarify. So I wish I didn't use Canvas, but our college goes with a Canvas, and well, that causes all of these confusions. So don't panic, don't be confused. You can always ask me in class what is going on, because it looks like Canvas is, well, I think it needs a little bit of extra work on it, but I don't think it's a bad program because there are way worse programs. So I guess the main idea is people start reading it and don't clearly see what's going on. And there are various examples of it. So don't worry, that's okay. On Canvas, I'll just try to put your class grade, and that will be after a couple of weeks or so, because I need to get some of the quizzes from you so I can, based on the quizzes, calculate the class grade. We'll talk about quizzes a little later. In fact, you're going to take one today. So I don't use Pearson. In fact, I told you also last time that I don't want you to buy anything. I don't want you to buy any codes to the Pearson or the textbook by Pearson. So I don't want to deal with that company at all. If you want to buy something, I had a student in the other class, he said, Alex, I bought it and I love it. Well, okay, you can enjoy it and you can ask me questions related to it, but I will use this free textbook. And I guess all you need is to have it, to download it. And anyways, while I had this story, looks like I multiplied 0.2 by 60 and produced 12. So that's 12 seconds. And this is the answer. So we actually can write it as a 40 degrees. And so instead of plus, I put and, or nothing, it's 19 minutes and 12 seconds. Maybe I should do another exercise like that, because to show you that it's not really that bad, because I guess with all these explanations, one may get a feeling that, oh, looks like there is a lot behind it. Well, not really. And that's what I want to show you now when I do another problem here, maybe the next exercise. So how about problem number 32? Look at this, 411 degrees. Wait, 411. Well, let me try 42. So, oh, sorry, that's 32. 32, that says take this 29, you can write it as degrees already, and 0.411 that I multiply by 60 minutes. So instead of 1 degree, I just put 60 minutes. So I multiply this. So go to the calculator. Notice that's the exact same thing I did with the previous exercise. I took the decimal part, multiplied by 60, and then multiplied by 60 again, the decimal part produced after that multiplication. So it looks like here, this product happened to be 2466, right? Minutes. So now I already know it's 29 degrees and 24 minutes. So I take only whole part. And then I need to take the 66 hundredths and times it again by 60. But now I multiply it again by 60 seconds. So it's 66 times 1 minute. So instead of 1 minute, I could put 60 of these little seconds, 2 primes. And we should get the answer at this stage. So just take whatever decimal is here and times it by 60. And that's our result, 39.6. So once you know it's 39.6 of these seconds, when you say, Alex, should I multiply this by 60 again? Well, we don't really have.
I'll be right back, Professor.
Okay, that's fine. Should I? We're not gonna wait. What you can do is.
I'll be right back.
I'll
be right back.
You'll be right back. I got it. Thank you for telling me. But the point of story is that I record these lectures. So if you miss it or miss a part of it, well, no need to worry. I will email you a recording. So you can always check the recording. And if you see the quiz at the end, well, do the quiz and send me back the answer. And that's fine. So anyways, how do I put this 39.6 seconds down? Well, it looks like what I have to do is round it. So do my best to get the closest number. Now, it looks like that'd be 40, right? 39.6 is approximated by 40, and that's the way it is. So it looks like we have result. So I just mentioned word quiz. So I'd like to do another exercise and give you a similar one for a little quiz. So I want to give you something in form of number 23 exercise. So what I want to do is maybe number 25. And what this is all about is dividing by 60. So in this group of problems I just looked at, we multiplied by 60, but now we do dividing by 60. So if I look at 25, then we can write this as a 1 degree and 2 minutes, and minutes were turning into 1 degree over 60. So it'd be 2 over 60 then degrees. And then for the seconds, we used to put this 1 over 36 hundredths of degrees. So if that's a 3, then I put it over 36 hundred. So it's not really that bad. And then I need to use a calculator, of course, to get this all put together. Without a calculator, it'd be very time consuming. I know some people can do this, but I don't think there is a point in actually doing all these divisions by hand. So 3 you divide by 36 with 2 zeros, and this is it. Here's our decimal. This be 1 point, I just copy 0, 3, 4, 1. One is Alex, take it easy. You just want to get a hundredths, right? Okay, so it's 1.03. But if somebody writes for me 0, 3, 4, 1, ... that's absolutely fine. I never pick on these little details. So I'd like you to try analogous exercise. I think the nice one here will be problem number 27 that has 9 degrees, 9 minutes, and 9 seconds. So the advice is look at what I did in problem 25. So I divided by 60 and then divided by 3600 and put them all together in a calculator. So you were asking what's for homework. Well, do same problems that I did today again over the weekend, and that'd be a good idea for the homework, because technically, if you get this homework done, then if you get these problems done, then the others will be same exact but different numbers. So it doesn't matter, you put 260s or 560s or whatever over 60. I never call the homework because I never call the attendance in my classes because I think it's a waste of time. What I do though is I give you a quiz. And right now I ask you to do a quiz. The quiz is exercise 27. And when you put your answer in the chat, in this Zoom chat, I will see that you were here because you took the quiz. And if you don't put the answer in the Zoom chat, you can email me the answer. And I will see that you are with us because, well, you're doing problems in this section. So it's not as crucial for me that you are present at that same moment and you're doing this at the same moment, this exercise. You can do it a little later. Sometimes people are just driving the car at the moment, they can't do it. I don't want you to get an accident or something, but you can email me because I check my emails and I will get the result. But you don't have to end email and put the answer in the chat. Just please make sure you put the answer only to my name. Don't send your answer to the whole class because they may get different answer and they will get confused by that. So send it only to me. When you do the chat, don't worry, just find my name in that blue rectangular box before you send the reply. So find my name and send it only to Alex, your answer. Because otherwise everyone in class will see it.
Professor,
Yes.
sorry to interrupt. I just wanted to ask a question about how you got it. Like, how come you're doing it with minutes? Because I was reading the problems. Yeah, I just don't
Multiply
understand.
by 60 or divide by 60, depends. Minutes, you divide by 60. Seconds, you divide by 3600.
Okay. Okay. Thank you.
You're welcome. Yeah, look at the previous exercise that I just did. So we had 2 minutes. I put it 2 over 60. We had 3 seconds. I put it 3 over 3600. That's it.
Oh, because the problems, like, let's say, for example, 25, 1 would be the degree, 2 is the minutes, and 3 is the seconds.
Yes, and there are little
Okay.
symbols here. It's like 2 of these things, that's minutes.
Okay,
And
thank you.
3 of those seconds.
Thank you.
Yes, I think that's a good question. Other people in class may definitely utilize this, right? And again, I'm gonna, I guess, stop recording and email it to you a little later. It takes a Zoom to process these files sometimes up to 5 hours, these recordings. So that's why I can't email it to you right after class. You just need to wait for the Zoom to process it. In fact, I can email the link, but you won't be able to open because Zoom did not finish processing.